Hello, Algebra 2. I know we are all so excited to have a snow day. Woo! Well, part of a snow day. Well, anyway, I thought I would make a video just working your homework problems from last night. And I'm going to work each problem out, so feel free to fast forward and skip around to just the ones you have trouble on. But I just thought I'd send you this video because we need to keep going, so we'll be ready for our test that's going to be on next Friday over Chapter 5. So your homework tonight is just more of these problems. So hopefully by working the homework problems from Check Your Understanding, that will answer some of your questions. Feel free to email me too as you're working. So I'm going to start with number 1 over here. All right, so we look at it, and first question we're asking ourselves, and the directions are to factor completely. We see if there are any greatest common factors. We look for a GCF, and there's nothing that goes into all of those terms. So then I ask myself, how many terms do I have? So 1, 2, 3, 4, 5, 6. So I'm going to try grouping, and again, this is one of those where we look and see what do we think they have in common. So I see that I can pull out an A and I can pull out a B if I group them like so. So I'm going to pull an A out of here, and that leaves me with 3x plus 2y minus z, and when I pull a b out of here, I'm left with 3x plus 2y minus z. It's magic. Of course, when you do grouping, if you don't end up with two sets of parentheses like these that match, then you haven't accomplished anything, and you either need to try grouping a different way, or it can't be grouped and potentially is prime. So now, the thing that I just highlighted in blue, that is my common factor. So I'm going to pull that out to the front. Of course, it doesn't matter which order you put your factors in. So if you write a plus b first, that's fine. And that is my answer. Okay, so now I go to number 3. Well, this only has 2 terms, so I know I'm not going to be doing grouping. And there's not a greatest common factor. We look for that first. So with 2 terms, I can ask myself, is it a difference of squares? Obviously not, because that is not a difference, and those are not perfect squares. So the only other tool I have in my toolbox for things with 2 terms are, could it potentially be a sum of cubes or a difference of cubes? Certainly, I recognize that is a perfect cube, and that is a perfect cube. So I might be a little curious. However, 2 is not a perfect cube, and neither is 5. So it's not a trinomial that I can factor. It's not a sum of cubes. It's not a difference of cubes or anything that fits in my pattern. So I'm going to assume that this is prime. It cannot be factored. So now we go down to number 5. And remember, on this video, you can press pause at any time if you need to stop and work something, or you can fast forward and skip to a problem that you have questions about. All right, so first question, is there a GCF? Yes, there is. We can pull out a 12q. And that leaves w cubed minus, if I pull out a 12, q cubed, right? So the q cubed is just going to be, the 12q is going to be hanging out to the front. And then I notice if I look at that as a perfect cube, and that is a perfect cube, and they're being subtracted. So I have a difference of cubes. So this is where I remind myself, okay, the cube root of w cubed is w. The cube root of q cubed is q. So I know that this should equal 12q, and I have a small set of parentheses and a longer set of parentheses. And I know that I put my roots here. The w and the q are my puzzle pieces here. And then to fill in my 3 pieces over here, I square this. That gives me that. I square the q and put it here, and then I multiply those together in the middle. So I've now placed my puzzle pieces, and now I'm going to figure out my signs. And so I know this is where I can use, for my signs, I can use SOAP. Same, opposite, always positive. And when you say the same, you're comparing it to your original in your difference of cubes. Sorry, right there is what I'm trying to point out. It was subtracting. So I keep the sign the same first, then I make it the opposite, and then this is always positive. Okay, so we have factored it completely. This trinomial that you get here is prime. It will not factor. Let's look at number 7. All right, again, is there a greatest common factor? Yes, there is. I can pull out x squared, and that leaves me with a to the 6th minus b to the 6th. Okay, and now I ask myself, do I have how many terms? I have 2 terms. So it could be a difference of squares or a difference of cubes since I'm subtracting. And honestly, you could do this as either one, because that is a difference of squares and it is a difference of cubes. So I'm going to do, since maybe right now on your mind is the difference of cubes, since that's what we've been practicing. Okay, so the cube root of that would be a squared, right? Because a squared times a squared times a squared is a to the 6th. And b squared, remember if I do this and I cube it, that does give me a to the 6th. And if I do b squared and I cube it, that does give me b to the 6th. So I know those are my roots. So x squared is hanging out. I have a small set of parentheses and a longer set of parentheses. So I put my roots in first, a squared, b squared. Then I square those. And what happens when I square a squared? I get a to the 4th. And when I square b squared, I get b to the 4th. And when I multiply a squared times b squared, I get just that, a squared, b squared. And now I'm going to fill in my signs. I'll do a different color this time. So this was a subtraction if I'm thinking of a difference of cubes. So I keep the same sign, the opposite sign, and then always positive. Okay. And now we have to be really good detectives and look at the 2 factors we created, right? I have to look at this and ask myself, can I factor it? And I look at this, can I factor it? Remember, we've said this will almost never factor it. I think it's safe to say it will not. But this is a difference of squares. If you recognize that's a perfect square, the square root is a. That's a perfect square, the square root is b. So whoops, I'm just going to erase that so it's not in my way. So now I have x squared times a squared minus b squared factors into a plus b, a minus b, and then this long a to the 4th plus a squared, b squared, plus b to the 4th. And there you have it. All right, and now we get a little bit of a break here because, oh, hallelujah, there's no GCF, right? Nothing goes into it. It has 2 terms being subtracted. So hopefully, if I can factor it, it's a difference of something, right? And it looks like that is a perfect cube because I know that 2c, if I cube it, gives me 8c cubed. And here, 5d, if I cube it, gives me that. And this, we just said cube it, gives me that. So I do my small set of parentheses and my big set of parentheses, and I put my roots in, 2c and 5d. And now remember, I square this. So if I have 2c squared, that's what I put first over here, and that's 4c squared. And then over here, I put 5d squared, which is 25d squared. And then in the middle, I multiply 2c and 5d, which is 10cd. SOAP will help me do my signs. I keep it the same first, then the opposite, and then always positive. This first factor is linear, so it's not going to factor. And I know I'm not able to factor that other piece, so we are finished with that one. Now, let me make sure my directions haven't changed over here. 9. Yep. Okay. Now, number 11 is a little different. The directions say to solve this equation. And we reminded ourselves yesterday, when we're solving, we're finding the x-intercepts, right? So that's why we have that 0 there. We set it equal to 0, and then we solve. Well, this one looks a little different because it is a trinomial. There is no greatest common factor. And normally, our trinomials factor into 2 sets of parentheses, right? And we'd have an x and an x. But those give me an x squared. I don't have an x squared here. I have an x to the 4th. So then I think, wait a minute, what can I multiply by to get and create an x to the 4th? Well, it could be an x squared and an x squared. And then I'm able to factor this as usual. So here's a tip, and you might want to write this down somewhere. When you look at the degree of the first term and the degree of the second term, if the degree of the second term is half the degree of the first term, the polynomial, that expression or equation you have, can be written as a quadratic. So you can factor it. Using similar strategies. So feel free to pause if you need to think about that for a minute and let that sink in. Okay, it'll factor like a, oh, and this is if it's a trinomial. I should have prefaced that. I mean, we're working with a trinomial. So let's put at the top, in a trinomial. Don't want to take for granted that you understand that is what we are focusing on right here, what this applies to. So 2 is half of 4. So we know, okay, this is a trinomial. The degree of the second term is half the degree of the first term, so it should factor like a trinomial. So that's why I would try this 2 sets of parentheses, set them equal to 0. Well, if I want x to the 4th, that should x squared and x squared give me x to the 4th, right? So then, just true to form like you would do, I need 2 numbers that multiply to give me 48 and add to give me negative 19. All right, so they multiply to give me 48, add to negative 19. I know they both have to be negative. So already I'm thinking, ooh, I know 16 times 3 is 48, and if I make both of those negative, I indeed get 19. So I have x squared minus 16 and x squared minus 3. Okay, now, just like before, once we have 2 factors, we can set them equal to 0 if we want to solve and find the roots or the x-intercepts. So I take x squared minus 16 and set it equal to 0. And x squared minus 3 equal to 0. And before, we might have had something simple like just x minus 16 equals 0, and that was easy to solve, right? We would get x equals 16. Well, now, because we have this squared, there's just an extra step involved. We're still just solving. So I would say, okay, I know that that means I can still add 16. And I get x squared equals 16. Take the square root of both sides. And you get x equals plus or minus 4. So I'm going to do the same thing over here. I'm going to add 3 to both sides. And I get x squared equals 3. Take the square root of both sides. And I get x equals plus or minus square root of 3. Once you have a factor that's a quadratic, even if it's not something that simple, like we were able to use the square root method here to solve, any quadratic, though, is solvable. Remember, you can try to factor it if it factors. I could have factored this. That factors into x plus 4, x minus 4, right? Still gives me the same answers. You can use square roots. You can use factoring if it's possible. But if all else fails, every quadratic can be solved using, drumroll, so don't forget that. Okay, that will help you. So those are my answers for that one. Let's go on to number 12. All right. I'm solving this, so I'm going to factor it, right? And it only has 2 terms, so I only have a couple tools in my toolbox. There's no GCF I can pull out. So I ask myself, is it a difference of squares or a difference of cubes? Because I am subtracting. And I know that is a perfect cube, and that is a perfect cube. So it must factor into x and 4, and then my big set of parentheses, which is going to be I square the x, I square the 4, and I multiply them together. And then I do my signs. I'm going to put those in. I keep it the same, opposite, always positive. Now, if I'm solving, I have to set both of those factors equal to 0. So I say x minus 4 equals 0. And I say this big thing, x squared plus 4x plus 16 equals 0. Well, this one's easy, right? X has to equal 4. Here, this is not going to factor. Right? There's nothing I can multiply to get positive 16 that's going to add to give me 4. So that's out the window. But I am going to say I can do the quadratic formula.